Thunderstorms. Of all the major storms, pretty much everyone has at some time experienced a thunderstorm. So what's actually happening? Well, the first step is uplift. So this is the warm, moist air. That is rising. So you have this air moving upward. Usually it's going to be associated with a cold front or just very hot temperatures. If you have, kind of the typical Florida summer thunderstorm, that's going to just be the hot air, the hot temperatures triggering that. Or it's going to be a cold front. Either way, you get the air moving upward quickly. Up. So the part that we really think of as the thunderstorm is the mature stage. That's when all the action happens. So what's all going on here? Well, first you get the formation of what's called an Anvil Cloud. And this is due to the strong uplift. So you've got the air rising, and it's rising so high that it's actually hitting the stratosphere. Now recall, stratosphere is where the temperature rises with altitude. So down here we are in the troposphere. Helps if I can spell. And so it's getting colder. So our temperature drops with altitude. So that's where the cloud formation is going to occur. But once it hits that boundary, the temperature is getting warmer again, so you're not going to get any more clouds past that point. So you get this very flat top of the cloud as it hits that stratosphere, because it's now going to push the air out to the sides, and that creates this anvil shape. So mature stage, that's when we're going to get our strongest rain. We're going to get lots and lots of rain coming out of this cloud because you've got lots of condensation. So your water droplets are going to be large and they're going to start falling downward. This is also when you get lightning and thunder. That uplift generates friction in the cloud. And that ends up stripping electrons from the water droplets. From water. And so you get this net charge. And so the lightning is a result of that net charge. It's basically trying to go back to neutral. So it ends up giving you this, lightning bolt because it's trying to get its charges back. And that's essentially the current of the charges recombining with the atoms. And then the thunder is the shock wave that's produced by the lightning. So when the lightning occurs, it creates this shock wave within the air around it, and we hear that as thunder. Hail is often associated with very strong thunderstorms, and again it's due to that uplift. At the high altitudes, you're going to get ice formation because it is so much colder up there. But the uplift prevents it from falling. So the ice gets bigger. Until it's too heavy, and so it falls. Now, if it's not a lot of uplift, that's going to melt before it hits the ground. But if there is a lot of uplift, then those ice crystals can get quite large. They can just keep building up and building up until finally it falls. And even though it will melt a little bit on the way down, you still get some solid pieces. And that's what we see as hail. So when you see really, really large hail, you know you have a huge amount of uplift taking place. The final stage is when the storm dissipates. And this occurs, hang on, let me make sure I spell that correctly before I keep talking, due to the falling rain and hail cooling the air down. And so that cuts off the uplift. So now you've got, cold air is coming down, being kind of dragged down with the rain and hail. So you don't get that hot air rising anymore. And so, nothing is feeding the storm. The storm's going to start falling apart at that point. And that's when your thunderstorm comes to an end.